Hello, welcome to version 3.5 using the new limit function found in the calculations menu. We begin by graphing some typical functions that you would find in a pre-calculus course or perhaps a beginning calculus course. Here they are. I have 4 functions entered in here that look pretty familiar, especially if you're taking this course now. When you get to the section on finding the limit at a point, these are typical looking functions. So let me graph these. Of course, they're going to show up in the standard window, and I'd like to zoom in just a little bit, so I'm going to zoom in a couple of times. And of course, the point of interest here would be when x is 0. We see that the red function sine of pi over x oscillates as you approach from the left or from the right, and it oscillates between positive 1 and negative 1, or values, positive and negative values. And so we're told that, as is the case, that this limit does not exist because it will never ever be a value. It's always going to oscillate. The green line, x over x, of course we expect this to be the number 1 everywhere except when x is 0, in which case the function is actually undefined. The blue line, the absolute value of 1 over x, we can see that this is this function here. And of course I can drag this down and show you that actually these blue lines are just going to shoot off to infinity. And so we'd like to calculate the limit as we approach 0, because we know these blue lines are going to shoot off to positive infinity. And lastly, the purple line here, the natural log of x, we know that the natural log is only defined for values greater than 0. So it's going to hug this y-axis. It's never going to touch it, and it's never going to go to the left of it. So here are the functions that I've chosen. Like I said, there's some typical looking functions, and the point of interest would be the point x equals 0. So let's use the application now. We go to the calculations menu. We click on find the limit. And again, the point of interest would be 0. Of course, we could find the limit of any point. None of them are quite as interesting as 0. That's why I chose the 0. And we're going to try to find the limit of y1. That's the sine of pi over x. And we can see that the application returns the answer: the limit of f of x as x approaches 0 does not exist. And that's because, as I had mentioned before, this is going to oscillate from positive to negative. It's never really going to settle down on one value. Let's go on to y2. So we don't have to enter anything new. We just choose a new function here. Let's calculate this. We recall that we decided that the function itself is undefined when x is 0. However, as you remember, the function does not have to be defined for the limit to exist. And we can see that the limit of fx2 as x approaches 0 is 1. That's exactly what we expect it should be. As we're coming from the left, we're going to see the value 1. As we're coming from the right, we're going to see the value 1. That means it's the same value coming from the left and the right. Therefore, the limit does exist, and it is that value, 1. Let's go on to y3. So for y3, we have the absolute value of 1 over x. This is the blue line here, and remember it shoots off to positive infinity on the left and on the right. And you see that the calculator returns the answer that the limit as x approaches 0 does not exist. And that's because the little catch point here is, remember, for the limit to exist, the limit from the left must equal the same value as the limit from the right. Positive infinity is not a value. Therefore, the limit does not exist because it is not the same value from the left that you get as the same value from the right. Infinity is not a value. So while the limit from the left does exist, and it's positive infinity, the limit from the right does exist, and it's positive infinity. The overall limit at the point does not exist because infinity is not a value. Let's go ahead and do this last one here, y4. So for y4, we're trying to find the limit of this natural log function as x approaches 0. And you see that the application returns the answer undefined. And the reason I decided to put in the word undefined, I think you can see it here. Remember, I just mentioned the definition of the limit at a point exists if and only the limit from the left equals the limit from the right. Well, this function does not exist on the left, so therefore there can be no limit from the left side. There's only a limit from the right side. And so a lot of textbooks and a lot of instructors want you to say that it does not exist, and that's perfectly correct. And if that's what they want, that's definitely what you should say. I put in the word undefined just to stress the point that this function is not even defined for this space. Therefore, you cannot have the limit from the left, and if you don't have it, it cannot not equal the limit from the right. So it's just a little play on words. I don't think anybody's going to lose any sleep over it. Again, whichever way your textbook and whichever way your instructor wants you to write that final answer, that's the way you need to write it. You're in their class, and they probably know a lot more than me. So this ends the session on using the new limit function found in the calculations menu.